Hello YouTube, this will be our 5th visit to Ken's shop. We'll install cam bearings, we'll put plugs in the side of the block. You don't want to hear me talking, let's go to it.
Okay, so last time Glenn was here, Glenn and I finished honing this with torque plates. We walked through the routine of the stones, going to different grits to get the finish so that you knock the plateau down. So after that, the honing oil is expensive, so usually I let it drip dry a couple days. I rotate it around, try to get all the oil out of everything. And then what we'll do is we have a commercial washer over here. It has basically a detergent, and it's just like a big dishwasher. Oh, there's something in this one. Basically rotates, it's about 180 degrees. Won't take rust off, but will take debris, grease. I kind of use this for final wash only. Usually we bacon blast. That removes all the paint and the heavy stuff. So this is only for final wash.
Gets rid of all the grindings from the honing.
Exactly, honing, decking, everything that Glenn and I did on this block, it gives us a nice final wash. Sometimes I'll do it twice just to make sure, run a brush through all the holes. Prior to that, we tap every hole. I was just telling Glenn, my son was in here and retapped all the oil pan bolts, which are 5/16, 18. Just make sure everything's clean, no debris in there, any rust or particles. So after that, we're to the point to install the cam bearings. The cam bearings we're using, it's a Durabond 12 or CH12B. The B means it's got a backside turn. If you look, it's got a groove on the back. I don't know if a lot of people know they have these. When you get into the Gen 5 and 6s, they did some cool trickery with machining. They ended up drilling, if you look down in here, I don't know if you can see it, this hole right here is an oil galley hole that's drilled down through the valley that joins the main, and then this one goes on an angle and comes into there. So they kind of did a shared resource. See how it's scalloped through? They break through that bore. The problem is you want to oil on the bottom, or you want to oil somewhere between, I'd say 4 and 7 o'clock.
For pressure?
Yes, you want to make sure that the oil's in the load area of where the cam is. You know, we always know the load is down from the valve springs. So they offer these so I can position them so that the oil hole can be wherever I want it, and then the oil can still get to it.
So you don't have to line up a hole?
Exactly.
Okay.
These are numbered for position. They are all the same ID, but the ODs are different.
Okay.
They jump around, do different sequential order. So they tell you like 1 is this one, 2 and 5 are shared bore, 3 and 4 are. So I don't know if you can see that.
Oh, clear as a day.
So what we're going to do is we're going to install the second and the first cam bearing. I already did the other ones just to kind of shorten up some stuff. But this allows me, if you get a conventional cam bearing, it doesn't have this, like a regular 12 for a regular big block Chevy, because they had a groove on the backside. When it came to the later ones, they lost that. So this allows us to position this so that we can feed the oil where we want it. Usually I'll keep it either straight up or somewhere over here so it's in the direction of the rotation of the cam. So you're always riding on that film of oil. So we're going to kind of work from the back. The cam bearing installer, it hasn't really changed much. I was telling Glenn I do have a new one ordered, which is really slick. We were hoping it was going to be here, but next week. It's coming from California. This one is basically like a collet or an expander. As you bring this thing down, this diameter gets bigger, restrains it, holds it on center, and then use a centering cone on the back bore to hold your position and then drive it through. So it's a bushing, even though I know it's a bearing. It is made of bearing material. It's babbited. It's got a steel shell, just like your rod bearings and main bearings. So it is, you could scratch it real easy. So they're numbered. We already walked through the numbers. It's going to be number 2. We're going to put that in. Bring this down. You can see that down in there. Sometimes there's a prevailing chamfer. See how one looks a little bigger? I don't know if it's by design. They're not always like that. I think there's variation in their process. I always try to use the leading one. It almost looks like it's got some run out issues if I look at this. You see how that chamfer gets bigger and smaller?
Yeah.
It's just an edge brake, so I don't think it's going to matter which way we put it. And then this will go in here. Move that back. Slide this over the expander, like so. 7/8 somewhere. We're just going to snug that up. You don't really need to make it real tight. That's going to expand. I'm going to make sure I'm shouldered. And that's about it. Got a little LPS 1. We're just going to put a little on there. A little in the bore. Make sure it's lubed up. We're going to line that hole up where we want it. So that's where our feed hole is going to be. If you go too far, you can always tap it back. You can always check, make sure it's still tight. Yeah, we're almost there. A little bit more. Okay. One cam bearing installed. Wipe the oil off, you can kind of see it. So it sticks through on both sides. It centers. That groove is almost 1/4 inch, so there's plenty of real estate for alignment. It'd be hard to miss the hole. We're going to install the last one. Same process. The new tool's made by BHJ. It's pretty slick. It draws the bushing in or the bearing, so it really aligns good. It tends not to like wobble or walk side to side as you put it in. I can't wait to get it.
It's interesting what excites people.
Well, after 30 some years of either buying 2 sets of cam bearings because one went in crooked, and
Yeah.
once it gets distorted, there's no fixing it. Okay. And we're going to go a little bit more. I think that's good. And there we have it. Camera is installed. So I have another tool I'm going to show you real quick. I can't take credit for it, but it works really well. Nice, those look great. I'll be right back, let me just grab it. So for years, if you messed up a bearing or it went in tight, it could have been maybe the hole was a little out of round or anything.
It just happens.
Yup.
Yes.
You go to put the cam in, wouldn't fit in the bushing. OD of the cam was good. Bushing started out, but whatever how it pressed in there, it's either not round or distorted. So I don't know. 3-4 years ago, I'm watching somebody interview John Kazi, and he had all these trips and tips. And he talked about cam bearings. 40, 50 years of him doing cam bearings. He finds that it happens. What do you do? Well, in the old days, you would scrape it with a scraper, remove material, try to find the high spot. Some guys might hone it with a ball hone. They'll do whatever, or they'll replace it and try it 3-4 times with a different set, try to get that one. So what I did was, these are like sizing tools. They're 3 thousandths over the size of the cam journal. And what you do is you screw this right on that driver and you drive this through, and it's like a ball broach. It sizes the ID of the bearing. It takes all the high spots, knocks them down. These are made out of A2 tool steel, so they can handle a beating. And it's a game changer. Like now, you have a little tight one, maybe in a Pontiac or a Ford. I run these through once, put the cam in, all the high spots are gone. I wish I would have thought of it 30 years ago. So I've passed this on to all my friends that have engine shops. And I can't take credit for it, but I have about 8 of these now. I've been making them for every engine, so at least I have them. So,
Great. Now you do it on a lathe?
Yep. When I had access to a CNC, it was easier.
Yeah, right.
So I would blank them out, and then we would just size them. All right, so the next thing we're going to do is we're going to do soft plugs. We got brass. I wanted to ask you, Glenn, if you want to put these in after you paint or before?
I want to put them in now.
Okay, perfect. So pretty much brass is all we really use here. As long as it's available, you might as well. So if you look, these are 1.5/8. A conventional Gen 4 block is 1.75". So they had downsized. These are the same size as a small block Chevy now. I don't know if anybody knew that. We're going to install the cam plug, and then the rest are all these pipe plugs, quite a few. On the pipe plugs, we're going to probably use pipe sealant on all the threads. The internal ones, I just put oil on them. I don't need to seal them. A lot of guys think they got to seal them, but now you have all that sealer inside all your oil channels or anything where it could come out. I am going to use some sealer on these. I've done different things over the years. We used to always use number 2 Permatex. It's a non-hardening. It works well, but what I found works better on some of the older blocks if they have some pitting or something in the block and the bore. I just use RTV now because as you push it in the hole, it forms like an O-ring on the inside where it displaces it. And I think that works better for anything that has a little porosity or pinhole, not pinholes, but little variations in the surface. So I'll go grab that, and then we'll put these in. We're going to use RTV on this plug. This is going to go right in the cam there. You can see there's a chamfer. We're going to knock this down, try to keep it flat. I got a couple different ways to do that. And then we're going to stay just below that chamfer. So let me go grab that. So we're going to talk about the Gen 5 and 6 oiling system. Your main pickup, we were looking at it. Glenn knows this because he had already researched this. This here is our oil pickup, pushes in through this hole right here.
From the oil pump.
Yep, from the oil pump. Sucks it up from the pan, pumps it into here. They went and drilled a hole here across and then another hole here so that it joins and then comes over here. This is where the oil filter is. This is where your rubber seal seals. And then on here, you'll recognize this. We have it out right now, Glenn and I. But this would be your threaded boss where your oil filter will screw on. So what you have to be careful with, when Glenn first called me, I didn't know what this block was out of, but he had researched it and realized that he had to change it. What goes in this hole is what we call a bypass valve. It's basically a check valve. They come in different pounds on the spring force. I think like 10, 15, and 20. And there's another one on Gen 5 and 6s that goes down in this hole. And they use it more for a restrictor because what happened was when they put this provision in for either an oil cooler or a remote oil filter, if they didn't put a restrictor in here, the oil would flow through the filter, down the hole, cross over, and then feed all the mains and the rods. It would never go through the cooler. So they said, well, let's put a restrictor down in here. We'll just use a check valve. That way, if it ever gets plugged, it'll always open. And that hole has a 1/4-inch hole in it. So now it's a shared thing. So at least some oil goes through, some oil goes through the filter. So you always kind of force it through. You don't totally block it off. But what happens is when people want to get rid of the oil cooler, say the line rots out on a truck, they'll go and plug these, not realizing that they didn't take that restrictor out. Now you're running all your oil through a hole that's about a 1/4 of an inch to feed all this whole engine. Usually it doesn't end well. Usually you end up spinning a main bearing or something. So just a little tidbit. I hope everybody, when you get one of these blocks, you remember that. At least research it, go online.
It's well explained.
It's well explained now. 25, 30 years ago, it really wasn't out there. But even GM, I think, has publications that list all that. So that's generally how it goes. You look at these and you would think they're joined. They're not. You're going to have this one breaks into this hole, and then this one goes up into this hole. So it's really two separate, it's just a loop that's closed off. It doesn't join anything other than the cooler, then a return line. So that's kind of where we're going to stop with that. And now we're going to get ready and we're going to stand this block up. We're going to put these pipe plugs in the cam, put that pipe plug in, that one, and then we'll drop it back down. Put the soft plugs in the front plugs, and then we'll be ready for assembly, which will be hopefully our next episode.
Outstanding.
Okay, let me stand this up. Yes, it's heavy. I just find it's easier to stand it up. I want this very shallow cam plug to always go in straight. And I do like when the numbers all line up. So let me go get some sealer. We're going to put a little sealer on there. And okay, we're going to put a thin film around this bore. Don't really need a lot. But what it'll do is it will push down in there with it. I kind of like when it does that.
And it lubricates nicely.
Yeah, lubricates. It gives it a nice seal. And when it cures on the inside, it's kind of like a little barrier. I mean, I like silicone. I just don't like a lot of it. So we're going to use a flat piece to get it square. And then we're just going to tap this down. Just below that chamfer. I think we're good. Wipe the excess off. And we have a cam plug installed.
And we put something on.
Yep. Now we're going to do these are 1/4-inch MPTs. We're going to do 3 of these. I think I'm going to leave this one out. We're probably going to tap into that when Glenn primes this. Don't need a lot of sealer. So if anybody's online, check out John Kazi. Really great guy to listen to.
There's a couple good ones out there. There's a bunch of bad ones.
He's definitely one of my favorites. So. Okay, I'll snug those up. Okay. Okay, I think we're good there. We're going to set this back down. Before we tip it down, we're going to plug. There's 3 1/8-inch pipe holes that cross drill. They connect this main oil galley to the cam bearings and down through the mains. So that's where they cross over. So we're going to put those in real quick. I usually don't use pipe sealer on any of the internal ones. I don't think it's really necessary. If anything, maybe just put a little oil on the thread so it doesn't gall.
At least it just bypasses it, goes right back into the oil pan.
Exactly. So when we washed this, we ran a brush, a stainless steel brush through all these holes. We also honed all the lifter bores
Great.
because what happens
Your son
is-
did that?
No, I did that.
okay.
Not yet, but what happens is if you don't do it, when these blocks are tumbled and shot blasted, all those edges get radiused.
Yeah.
They get peened over, so you want to just knock the high spots off. So when Glenn goes to install the lifters, they'll slip in real nice.
The last time I did it, I had 3 sets of lifters that had the links on backwards.
I remember you saying something about that too. You had all kinds of like little issues
Yeah.
with your valve train stuff, and it was good stuff from Edelbrock.
Well, it was from Comp Cam.
Oh, was it a Comp Cams?
It was in the Edelbrock
Brock
box,
box.
but it was in the Comp Cam box inside of the Edelbrock box.
How did you catch the lifter tie bars were backwards?
They weren't sitting square, and
And the bore.
they were cocked on the cam.
No kidding. Good thing you caught it. That would have been catastrophic.
Bad, bad, bad.
All right, those are in. I'm gonna set this block down. So yeah, we honed the lifter bores. Made sure everything was nice. Now we're gonna put these in. We're gonna use RTV. Same thing. Then film. We were going to put this on an engine stand. Unfortunately, I don't have an open one right now, so we will shortly. I was hoping to have that one ready for you.
Could have said something. I brought mine.
No, it's okay. It's an incentive to get the other engines done. Okay, nice thin film. I'm sure everybody has their own ideas of what works. I've been doing this for 30-some years. It kind of works.
That's just what I do. Same
All right,
thing.
so I'm kind of anal retentive. I like all the numbers to be nice and square. If somebody helps me and they put them in the wrong way, I take them out and put new ones in. So I like when they're just like that. And that's it. Wipe the excess off. Stops right in the chamfer.
What happens if you push it all the way through?
You got to take it out and start over.
How do you get it out?
I actually just use channel locks. I can grab it and
Oh,
actually
okay.
pull it right through. I mean, if you want, we could sacrifice
No.
what we do. These really aren't too bad of blocks to do. There's some room behind there. Some of the big block Chevys, this falls right in where the cylinder is on the back on the old Gen 4, so it gets very tight there. Excellent, those are great. Okay, 3 more of these, couple pipe plugs, and we're ready for assembly.
Uh-oh.
That's all right. Knock something off the table underneath. All right, those look nice. No marks. That's why the Delrin's nice.
Yeah. Did you get that? Did you cut that yourself?
I bought them. I found them online.
Huh. I know you
Just
can get,
true them up when you need to, so.
yeah.
All right, we have these 3 plugs, and that's going to be it. 2 back ones, and we're good for assembly. We already checked all the oil clearances when we line honed it. We will check them again. I'm just going to squirt a little oil on the threads. So we'll probably walk through that, just verify that nothing changed. We didn't mismeasure anything. If it
Wait, you
looks good.
put a mic inside the,
Yeah, we'll bore gauge it again, just
Okay.
like we did over here. You know, the crank will be all washed, polished. I usually take what they call a cork bonded belt. It's like an 800 grit. And we're just gonna kind of give it a nice little polish, luster, make sure there's no edges and nothing on there. And we'll be good. Wrong one. Oh, wrong one. What am I doing here? There we go. I tend not to over tighten these. It's you know, it's pressure
yeah,
tight.
that's about right.
It's a I don't know if people realize it's a tapered fit.
Right, it's a pipe plug.
Yup, it has an included angle of 1 degree and 27 minutes. So as you wedge it in there, it tightens and tightens more on itself. Okay, put one up here. I'm going to leave these coolant passages out. When we have it on the assembly room, we'll put brass ones in there, or if you might have petcocks. I don't know if you drain
Oh,
this.
brass.
Okay.
I don't use petcock. I don't like them.
Okay.
I had them leak.
So I have brass plugs we use just for that.
All right, I can bring them if you want them. Otherwise,
Whatever you want to do. If you have something like, that's fine. I have, you know, internal hacks, and then I have
no, I like
the external square
right.
or external hacks. That's probably what you like. They're easier always to get
3/8.
out.
Yeah.
There's a couple fittings here. Those are actually not for that. Those are what that's where the knock sensors originally went in the block.
Where's that?
Right here is where a knock sensor would have went. See, it's a blind hole.
Right.
And another one over there.
I tried to poke it out with a.
Yeah, you don't realize it, but yeah, that's what that is.
Okay. Yeah, this is the drain and this is the.
You got it.
Right.
Yep, the knock sensor. All right, Glenn, I think we're good.
All right.
Next, what we'll do is you'll come back. I'll have the engine assembly nice and clean, the bench cleaned off, everything laid out, and we're going to file fit some rings, board gauge the rod clearance, board gauge the main clearance, and then we'll assemble. Should be good.
Outstanding.
Okay,
Thank you.
no problem.
Once again, we have to extend our thanks to Ken for extending the courtesy of allowing us to be in his shop and allowing him to see his processes. If you enjoyed this video, there will be more.